Okay, this exercise or this lesson, we are going to learn the positive integral index, okay, which you learned, okay, before. Here, just to do some revisions, okay. First, we have to remind ourselves the laws you have to know, okay. Just copy down. The first one. When we do a n power times a m power, okay, what we have, you have to know what does it mean, okay? A to the power n, meaning that there are n a's times together, and then here there are m a's times together, okay? So all together we have what? N plus m a comes together, okay? We can generate this to the other version, okay? We try to extend a little bit. We don't have to be just a little a. We can just change it to a block, okay? A big block. This big block can be a negative number or very large expressions is okay. So when you see this, as long as you can ensure, okay, the base, what we call the base, they are the same. You can do this, okay? You have to memorize this kind of thing, not only just here, okay? This is the first one, okay? And the second one, when you do a n, and then you give a bracket, and then to the power n, meaning that you do a power to power, okay, or power of power. What you have to do the multiplication, okay, not do the plus, okay. So we extend it a little bit. It could be a block n power, then to the power m, okay. You can keep writing the power. For example, you give one more power, k. Don't be afraid here. As long as it is power to the power to the power, then copy the base, keep the power doing the multiplication. Okay? So this is the what we call a very simple one. Okay? Third one. When you're doing a times b, give a n power, what you have, as long as the things inside the bracket doing a multiplication or division, you can give them n power, okay? You can just distribute the n to every one of them. So what we have, the next one, you can have a over b n power, then you can distribute the n to the power of them. Okay? So here we can extend a little bit more. When you see expressions very large, okay? For example here, x, y, okay? And then a, b, c. For example, we give some powers of the unknowns inside. For example, it's here, y square, a to the power 3, and then c square, something like here. Okay, then you give a power n. So, can you just put the power inside? Yes. Why? Because all these unknowns here, they are just doing multiplication or division. No any addition or subtractions. And then you can put the power inside. Okay, here. X to the power n is okay. And then y square, 2n. So the 2 and n should be doing a multiplication, not doing addition, because it's a power 2 and then to the power n, meaning that power to the power. Okay? And then here again, a 3m, b n, and c 2n. Okay? So you better learn this. You better learn this. Okay? So keep going. And then 4. What we have, sometimes you do this, a to the power n divided by a to the power m. Okay? Sometimes we don't like this kind of expressions. Okay? Normally we do like right here, write this. Okay? We write the fraction form. But how to simplify this? It depends on which one, I mean n or m, which one is larger. Okay? So you have to divide it into two cases. The first one, I use the a here, the first one. If n larger than m, then a to the power n over a to the power m will become, you always use the larger power to minus the smaller power, okay? Meaning that here you're doing what? Always do n minus m. But where is your result? I mean, is it above or at the bottom? It's above, okay? So keep yourself doing like this, okay? So we draw a fraction like first, and then we do the big minus the small. I mean the n minus m, okay? Because here you have to put the result above, so you keep the a. The a is still there, okay? We don't have anything here, it's just 1, okay? You put a 1 here, and then write one more step, it's just like this, okay? This is very, very important. And then the second case, if n less than m, what we do then, okay, the same expression here, but this time m is larger than n, we do m minus n, but the result is what? Is at the bottom, okay? And then the 1 here. You cannot remove the 1, so you have to make this as the result. Understand? So just a little bit thing we have to remind, very important. Okay. The power of a negative number. The power of a negative number. Okay. So the first case, you write a. We write this. A block n is just equal to block n, nothing. Okay. But let's keep going. If there's a block minus block n, so can we just remove the minus? No. Okay. Because the minus sign here is doing nothing with the n, okay? So we keep the minus and then copy everything. Seems that we're doing nothing with it, okay? But you keep copying, you find out something, okay? When you go to this kind of expressions, you give a bracket to a negative thing, okay? And then you have a power, okay, n. So how to simplify this kind of expressions? It depends on whether n is even or not. Okay, so you have two cases. Okay, break down to two cases. First one, okay, I use this first. If n is even, meaning that n can be divisible by 2, okay? So these expressions can just directly become positive. Understand? You remove. So we can give them examples, okay? For examples, e.g. many examples. Minus 2 to the power 2, you can just remove the minus become 2 to the power 2. Of course, equal to 4. Okay. Here, how to decide to remove? You look at the power. The power here is not positive, but even. It's even. Okay. Try more. Negative 3 to the power 4 is equal to positive 3 to the power 4. Understand? Okay, you can give a big expressions, for example, minus or a over b and then times x and then y y here, okay, y here, and then it's a power 4. So what is the result? The first result, I mean, is it positive or negative? Because this is 4. Negative, it's a positive. So the next step, you don't have to write the negative. You just distribute the 4 to every unknown. Okay, this is very important thing. Understand? Every time you see when there is a negative sign inside the bracket to the power something, okay, you have to recognize where what is this? Okay, is it positive or negative? Understand? So you can go to the case 2. If n is odd, okay, then what we have? Still the same expressions, but if n is odd, you have to keep the minus, understand? But you don't have to write the bracket. Okay, they're different. See, they're different. Okay, so we can give some example. For example, minus 2 again, but this time is a power 3. Because this 3 is odd, so what you have to do, you have to keep the minus and then still write in this. Of course, the result is minus 8 because 3, 2 times together equal to 8, not 6. Okay? For example, minus 3 to the power 7. Okay? Because this 7 is odd, so you keep the minus and then 3 to the power 7. Understand? So keep going. For example, you give a minus something x squared y and then ab to the power 3c power 4, and then you have a 5 here. Okay. So because this 5 is an odd number, so keep this minus. Okay. And then draw a fraction line. You can put the minus at the numerator or the denominator is okay, or you just pull out here. Understand? So all the things you can do the power 5. Okay, 2 to the power 5 is 10, and then this 5, this a 5, b 15, c 20. Understand? Is it okay? So this is the what we call the very basic law of index. Okay, based on these laws, we do some revision, simple review. Okay, then we can go to the exercise. Okay.